Hi! So, in this video I'm going to try and talk about my project Wordsquares, and I apologize for the horrible sound quality despite my best efforts. So here is a word square. So you can see 9 letters where all the rows and the columns are words, in this case the same ones. So man ape new is man ape new. So that's just one small example of a word square that is taken from this fairly extensive database that I generated myself using certain algorithms, recursive algorithms. And so the first part of that project was to generate all these squares, and after that the goal was to try and find features in them so that it would be possible to visualize that whole data set and possibly find good squares in them. So here you can see I've got several features like redundancy, inner redundancy within rows or columns, or common words between the two, or I can have specific formal features like the kind of letter patterns that you get in certain squares, or the letter diversity, such as like basically the size of the set of letters used, as well as later a count for letters, so you can have an even more precise idea of what letters are used. And every time I'm transforming that into classes, and so using classification on all these squares, I build a feature vector. Here you have the feature vector for the various formal features, and here for the letter composition. Here you have an example. So here you have twice the letter A here and twice the letter E in all these words. And you can also check whether there are words from that dictionary, the same one I used before, in the diagonals. And all that is encoded in the feature vector. And after that I tried to look into semantic features, and for that I went into the exploration of word2vec, which is an embedding of words into a vector space, meaning that similar words will be placed in a similar location in that space. So you can see, for instance, here you have a function to get related terms. So intractable is similar to vexing, insoluble, thorny, knotty, etc., etc. So in this case, unfortunately, I couldn't go as far as I wanted to, but it is still possible to calculate, for instance, what is the maximum similarity within the square. You can see here, with a very high score, I could get only 22 squares, and in these squares you have very similar words like she and her. But you can do also other things, such as, for instance, try and see what squares have the least amount of very dissimilar words, so that are more homogeneous, or on the contrary, more heterogeneous. And so that would be a more semantics-based way of adding more features to these squares, which is a further development for this project. And once that is done, you can move on to the visualization part, where I've been reshuffling the data here, and then once I have them as squares and as feature vector here only with the formal features, I can use the t-SNE algorithm for dimensionality reduction and apply to that, obtain coordinates in 2D, and then use that library bokeh. Here it's actually stuck because it takes quite a lot of my computer power to generate, and you can see here the distribution of the squares with that particular result. And in this case I was focusing on that point, which had quite a few squares that have the same letter in the middle of the edges. You can see here it's A's, but here you have E's here, and so yes, the idea of trying to generate visualizations of these databases and be able to explore that was part of the project, and is still a work in progress for the future.